Hello everyone, welcome to Cassini2.0. My name is Marcos, and today we're gonna dive into some details about Cassini2.0 project. So I'm doing this file. I'm this step here. It's in Portuguese Brazil. However, it's full of very interesting and important details about physics, formulas, the altitude roadmap, starting from the ground, and each more distance from the ground, we have different perspectives, different gravity, different forces acting in the structure. This is a small roadmap about the mission science here from Earth until crossing the vast deep space, gathering flyby assistance, gravity assistance, slingshot assistance to get into Saturn. Each DSM, so what the spacecraft should do when arrive on Saturn after the Saturn orbit insertion, and what components it must be used. And also here I'm working this step right now to create simulations with all these tools. Let's see now the spacecraft Cassini-Huygens. This is our beloved spacecraft. So something that I want to point at here, it's the instrument. So if we ultraviolet, if we activate also infrared and also this camera, we see these three lights. Nevertheless, it's just one point, it's pointed by just one specific point of space of time. So this gave us some problem, because during the flyby of Jupiter or even Venus, to point this instrument to the planet, so the GPL team must change whole position of spacecraft in this space, change the reaction rails to point these lines. So it should be created at least 2 or 3 points. But the NASA team did a very good work here. This is the magnetometer. It's a close distance for the center of electronic. And so I'm looking for studying about rockets, very teeny details. And this is the Titan Centaur used on Voyage 1 project. The rocket using on our spacecraft here, Cassini-Huygens, it was Titan EVB. It's a little different. However, it's the same family. This is the official document showing very technical detail about the launching. If you see the design of the font used in this document is a little old, but it's really interesting. I'm gonna share this link with you guys so you can see too. It's the diagram, illustrative diagram. And for here, we have the structure of the rocket. It's almost the same thing. Cassini-Huygens was a little different, but not at all, So from here, we have, I'm reading this, every day, gathering knowledge about it. And what I write about it too. So this is another document, very important too. And I'm looking for, keep learning, reading about the details of RTG battery. It's useful, we think about it. because these instruments that sustain the electricity of the spacecraft in the emptiness of the deep space. Another one is how the RTG, it's getting a very good work at Mars exploration. Miley and Perseverance hover. And now we're gonna see the blender. Yeah, the blender, this is the model. I'm working harder than every day. Now it's almost done. If you see here in the Radio X, you can see 2 tanks, biggest one. This is the mine propellant used in a propulsion system. And the background here, we have the gimbal system. And inside of it, we have a small one to the RCS propulsion system and helium. Nevertheless, helium is a gas that must be used to sustain the propulsion, so it must be stored in spherical tanks. So, if we keep diving into this model, we have the probe here, and also the probe have a tank too, and also independent gimbal. And I'm searching for things of what kind of welding we're gonna use to put this here. A kind of test of pressure, sustain, because this must be trapped into the structure of the spacecraft until Enceladus. We have 4 lines here, different than the first one. The same iron bar, a magnetometer, the 3 landing gear, 1 gimbal here, and this is where we have the hard mode. It's gonna be with a hard mode, a pyramid. Use it. However, in soft mode, heavy mode is used into the soil, for example, Saturn orbit insertion, or even in a landing on Mimas or Enceladus. And when into the deep space, to protect from the sun, it's just open the lines and transform it into this, something like that. It's just a first approach to represent the Cassini 2.0. I know we have more to do here, mining about animation of this skills. But this is very interesting how the things fit here. And I also want to use calculus. This is the internal point. To calculate so the volume of propellant using and what is the mass of it, each one of it, put it in a table, sum everything, and just we're gonna have a representative form of mass very close to the reality. Now, this is the source code that I'm working at. This source code is doing in JavaScript. I'm using JavaScript instead of C# right now because JavaScript have some more. We are free, in JavaScript a little bit, and this is very useful for us right now. So, all right, we can use Python too. Nevertheless, we're gonna start in JavaScript. This is the README. I'm gonna share with you guys this source code. It's on my GitHub. It's a public, so you can go there and watch what I'm doing here. This is a README, what I did to create the files of telemetry, with a small description about the structure folder. Here I'm working something. I was working in Matrix using C#, And here I'm working and using JavaScript, scheduling the time for each execution. So here in this file, I create the matrix, only square matrix for a while. How to get the determinant directly operating the memory. 2 by 2, 3 by 3, this is the Sahu shortcut. And determinant by Gauss, and the matrix in more than 3 than 3, 4, 5. And also the LUP. And here the traversal methods. I'm not gonna explain each detail of this source code. If you want, you can check it out on my GitHub, and also contact me. Let's chat about it. This is something of working with thread and parallel process in JavaScript. And this is my C++. I'm using this to trying to control a solenoid, a really solenoid, using a Uno Arduino and also ESP32 to control the activation of solenoid and sensor, already gathering experiences with handling this kind of real prototypes, For a while, it's very important to start to control the tension of the solenoid, electricity, electronic circuits, putting everything together. And the more this greasing I'm going to put in the more this is upgrading, I'm going to put in new things here. So, is this my Cassini2.0 project until here? And this is the files. Of course, it's very important. It's 8 files. Size from here in 97 until Enceladus. The speed of the spacecraft for each step of the journey. As sun as a reference and as a planet as a reference. It's a little different when the spacecraft is gathering the sun as a center of reference of speed. We're gathering the Earth, Aphrodite is Venus, Leo is Jupiter. I put the name of the planets in Greek. And I'm also writing very interesting topics of calculus by my own hands. Then I'm going to take a picture and share with you on my website. So is this guy with the video of today. I just want to thank you if you were watching here until now. And God bless America.